today we have a topic log-based protocol under the concurrency control. And what is mean by the concurrency control? We have seen what is mean by the concurrency control. Concurrency control is mostly applicable where you are talking about the concurrent execution. But when talking about the concurrent execution, the transactions, so how to manage or how to control those transactions, that is under come into the concurrency control. But during the concurrency control, we have found a problem, that is isolation. So isolation is basically an important part of the transaction processing system, or we can say transaction management. So I'm repeating this statement once again to all. So we have seen, or by the some example, the fundamental property of the transaction is most important part. But in the several transaction, this isolation property is not cope up with the preservation thing. So how to manage or how to ensure such thing, that is to be controlled by the some mechanism, and that is known as the concurrency control. So concurrent execution can be done by in a smooth way, but that should be controlled to manage the property, or that to manage the preservation of the isolation properties, and that is required thing. So we will see this concurrency control, and this part we have already seen study class. And what is the concurrency control? So we have also discussed this concurrency control, and the point you need to keep in mind, the concurrency control, basically it is very simple concept. When talking about the user's information, then user can read and write the data on the followed by the data items. And but now the point we need to keep in mind, we are not bound by only a single operation. In our information, our transaction can be composed by or integrated by the two different operations. Those are the read and write operations. So the concurrency is not a simple thing. It is a kind of the big challenge or a big matter to us, than how we can deal with. Since we are reading the transaction, it's no issue. We can read the multiple information from the multiple transaction, there will be no issue. But when we're talking about the writing, so at the time the in concept will applicable over there, that is a conflict serializability. So how to manage the conflict serializability, that is the most important part. And what is the conflict serializability? Of course, when you are writing something on the data item, and on the same time, or the other transaction also reading the same thing, so the conflict may occur. And we have the conflict serializability, in which what we need to do, we need to transform, or we need to convert the conflict serializability into the serial schedule to manage the to see the things properly. But all those things, by the some example we have seen into the our previous classes. So this is a very big challenge in the concurrency, so that would be managed by the concurrency control, and to preserve the isolation property. And this part we have already seen. And now why we need to use the concurrency method, so these are things we need to keep in mind. Once again, I am repeating over here. And to apply the isolation, of course isolation property should be maintained properly. So next point, we have the to resolve the read write or write conflict issue. So of course, while reading, writing, or write operation are performing by the two different transactions on the same data item, so that is conflict issue may occur. So how to resolve such issue, and to how to prevent from the such kind of issues, so concurrency method will be applicable. And if you're talking about the third point, that is a necessary point, the preserve database consistency. Of course, since when talking about the conflict serializability, so the or during the concurrency, so what is happening over there, we are dealing with the inconsistent. Since isolation cannot be preserved while we have when we have the inconsistent state in our database. So to avoid the such things, what we need to do, we need to manage our database inconsistent state to consistent state. So the point we need to keep in mind, if your database is having the consistent, of course it is a part of the property of the acid, that is the atomicity, consistency, isolation, and durability. So if you or if your database having the non-isolation property, then definitely the consistency property will be affect. So the point we have, when you are having the acid property on the database, then your database must be safe, or we can say the work smoothly without any problems, and there will be we will not lose any kind of the information uh, from the database after performing the read write or different other operation as our user required. And if you're talking about the fourth point, the system needs to control the interactions among the concurrent transactions. So this control is achieved using the concurrent schemes. As I told you so many times, the system is required to control the interaction among the concurrent transaction. Because why? Because we have the multiple transaction, not t1 t2, we can have the t1 to tn transaction. So when we have the multiple transaction, then how we can manage all those transactions by maintaining the concurrent executions. Why concurrent education is, I'm repeating once again to all, concurrent education is most important education, because serial education will take will busy with the processor, and so resource utilization cannot be done in proper way. So if you want to do see with the database, then your resource utilization must be proper utilized with the all the resource by the all the transaction. Definitely your transaction must be followed by the this what we have, the that is concurrent execution. And that is the part we have already seen into the serial schedule versus the seriality. So we have seen. Now let me clear to all once again. In the seriality we can perform the concurrent execution. So this is the point we need to keep in mind, the fundamental things of the each and everything we have seen properly here. I'm once again request to the all the students, this is the see, I'm requesting to all, please go through the previous slide and read the fundamental part of what we have discussed so many times. Each and everything is depend on the each and every part of the coming classes, and that would be the part of the today's as well. Because something is depend on the previous one. So advanced part is based on the fundamental part or intermediate part. So advanced part or fundamental part is intermediate part is not clear, then how we can jump to the advanced part. So this is the thing we need to cover up. So the concurrent, before learning the concurrent say control, we must aware about the concurrent education, we must aware about the seriality, we must aware about the what is the mean by the conflict seriality, and how to what is the sense of using seriality, and what is the sense of the serial scheduler, and what is the sense of the transition management. All those things we have seen by the 2 or 3 classes. So this is a point where we need to move into the concurrency control. So concurrency control have to ensure the seriality where we have the conflict seriality, and to maintain the consistent state. So this is the reason where we have to move to the concurrency method. So example, yesterday I told you so many times one example, but this time I'm taking the same example. It was already mentioned over here. See, uh, suppose you and your friends just want to watch a movie. Okay, so at that time you want to book a ticket by the online. No problem. You are the movie goer people. Then you can book. But at that time your friend and you are booking the tickets simultaneously on the same moment, same time. So the request which is coming from your friend or you, so the system will see who have, or the which request is coming from the which person or whose person. So you from your side or your friend. So the request which is coming the first, that will be counted as a first. So concurrency control will see that the request is coming from you side first instead of your friend. So you can, or you are able to book a ticket. And same thing we can see this is happening done into the IRCTC website. When try to book the railway ticket or any flight ticket, so we can also book, but we need to see, like us or like me, the other people are also busy with the booking the ticket. Now this could be happen when we are looking for the festival season or festival time. So while booking the ticket, tickets are booking very very fastly. After the few minutes you will see the 20 or 30 tickets are booked. So because at that moment the simultaneously other people are busy with that server or that system. So this is the things we need to manage by the concurrency control. So database will maintain the concurrency, and the concurrency is basically is a concept in the database which describe when we have the multiple transaction. Okay, this is the point we need to keep in mind. So that is the point we need to look into here, because we have the multiple transaction that is done by the concurrency control. Okay, so now the fundamental part of the concurrency control I tell you over here. So any doubt here what is mean by the concurrency control? Is it clear? Because uh, so far I've just described what is mean by the concurrency control and why it is required. And this is a revision part of the yesterday's class. Yes, tell me. Any doubt?
It's clear, sir.
It's clear because yesterday's we have already discussed, and now I have already described once again. Now For controlling the concurrency, we have some protocols, and that is necessary part. So here we have the different kind of the protocol by which we can do and by which we can manage. Now, as we know, the concurrency control, if you want to control anything, some protocols is required, and that is governed by the some rule and regulation. So protocol definition, you know about the part. What is mean by the protocol? Protocol means some set of the rule and regulation for by which we can manage the some information that belong to the protocol. So different concurrency control protocols offer different benefits between the amount of the concurrency. So they allow the amount of the overhead that they impose, and following and the concurrency technique in the database management system. One is a lock based protocol, two-phase locking protocol, and timestamp and validation. uh, Today we will see the log based protocol, and on the Monday we will see the two-phase locking protocol or timestamp based protocol. See, log based protocol is very interesting part, and this is a important part for the examination purpose, but truly speaking. Okay. And if validation based protocol is not part of the curriculum, so we will cover the log based protocol, two-phase locking protocol, and timestamp based protocol. So if time permits, then we will see the validation based protocol, but first we need to focus on the log based protocol and a two-phase locking protocol and a timestamp based protocol. So today we will cover the log based protocol. So I will take much time to explain more detail about the log based protocol. Why? Because when you understand the log based protocol in smooth way, then two-phase protocol, locking protocol, and timestamp locking protocol based protocol, you can understand in simple way. So let us move to the log based protocol first. So here we have the some part, and here we have the some theoretical part which describe the what is the sense of the log based protocol or the kind of the thing. See, let me explain the few things by the simple way, and I have written some theory over here for notes purpose, because by these notes you will able to understand what is the sense of the log based protocol. So, log-based protocol in database management system is a mechanism in which the transaction cannot read or write data until it requires an appropriate log. So, just like this is a point where we can say you are inside a room and I'm locking a room, then how you can move? You can move in your room. There will be no issue, but you can move out. You can move out from the room because I have locked the room. So when I'm just unlocking the room, then you can move out. So how you can move out after the unlocking? So that is to be point we need to keep in mind. We have the two important point. One is a lock and unlock. So these are the two different sub operation of the transaction management or any transaction. Of course, read and write operation are done on the data item. Let me clear to all once again. Read and write operations are the two different operations that can be done on the data item. But when talking about lock, so lock are the sub operation of the transaction which is to be performed on the data item to define that the item data item is locked or data item is not locked. If data item is locked, then it can be executed by the transaction till uh, till until we can unlock. So this is the point we need to keep in mind, and of course we have some example by which we will clear this concept properly. So log-based protocol have to eliminate the concurrency problem in database management system for the simultaneous transaction. Yes, of course, this can be done like this one. Same thing, you are booking the ticket, I'm also booking the ticket, so definitely system will get confused at the same moment. If two processes are coming on the same time, so how to manage the thing? So that is the thing we need to keep in mind. So concurrency problem can be eliminated while we are dealing with the simultaneous operation, simultaneous transaction. So we need to keep in mind once again, isolation is a property and that can be managed by the server. So here we're talking about the log-based protocol. So log is basically a data variable. So this is just like I'm speaking once again. It is a sub operation. So because we are passing some information to the log, so we can say it is a kind of the sub operation or it is a data variable. So a log is a data variable which is associated with the data item. So of course, as I told you, so this log signifies the operations on that can be performed on the data items. Locks in database management system help synchronize access to the database item by concurrent transaction. Since these are theoretical part, but you will understand this concept by taking example. So right now I will take an example, but before taking the example, just let me clear to all once again what is the meaning of the different kind of the lock mode. So before lock mode, so let me show the some example. See, in this example, look at this transaction T1 and T2. So log X we have, log XA we have over here before read and write operation. So since it is also possible, but what is the sense of the this uh, transition T1 and T2? I will explain, but if it is visible to all, the log X we have, log X we have. Now you can see the transition T2 log S we have. So what does it mean by the log X or log S? Okay, so we will see, but that is known as the mode of the log. So it is visible to all in transition T1, T2.
Yes, sir.
It is visible.
Yes, sir.
Okay, so before understanding this example of the log-based protocol, let me move to the theoretical part once again. To define the things over here, all lock requests are made to the concurrency control managers. Transaction proceed only once the lock request is granted. So just like this one, there are two rooms, A friend and B friend. So I'm just explaining this example. Just let me take an example, then you will understand. See, there are two friend. One is A and another is B. Okay, both want to communicate to each other. Okay, both want to communicate to each other, and they are free to move. And they are moving around here. There's no problem. So I plan. What is my plan? I'm locking A. So what I've done, I'm locking A. So I locked A and I lock B. Okay. Now what I did over here, I have separated both by locking. So now A is locked into the another room and B is locked into the another room. So they both friends cannot talk. Both friends cannot uh, move in other rooms. Now, so if the B friends just want to talk to the A, or if they want to talk to the B, it is not possible because both are logs. I This is the point. But when I'm unlocking A, when I unlock A, like over here, when I unlock A, so what is the changes which is done by this A friend, that is unlocked. So now A is friend and he is able to move inside the B, because now he is able to move. So he is out from the room, so he can go to the B. Why? Because he used any other mechanism to inside the room. So this is the things we can have. So this is a general example, but I will take the real example of the database management system, how it will be happen, so you will understand better way. So this, for understanding this concept, but here we have the term that is we need to understand there's a grant. So concurrency control manager, this is the point I'm speaking once again. Concurrency control manager will check which transaction is locked, which transaction is unlocked. Okay, or the part of the such transaction or set of the transaction or data item is locked. If data item is locked, then you will not allow to access. If data item is unlocked, then you are able to access. So for understanding this point, this is the thing which is done by the concurrency control manager. Now I'm repeating once again. So for the transaction manager, we have a transaction manager. Now those students who have just idea about the database architecture, I'm speaking once again, those students who have idea about the database management architecture, there was a point, there was a object which describes the transaction manager under the database management architecture. So in the database management architecture, we have a word, we have the symbol or object that defines the, we have the transaction, then how we can manage, that is a transaction manager. And unlike a transaction manager, we have a concurrency control manager, because we have a not a single transaction, we have the multiple transaction, thousand transaction. So if we are getting the multiple transaction, then how we can manage those transactions or thousand transaction at a time, and that is known as the concurrency control manager. So the concurrency control manager will check which transaction should execute first or which transaction should execute later on or after a few minutes or after some times. That is to be done by the concurrency control manager. So so if you see the transaction is busy with some other data, so we will log the data and the data will not allow to access by the other transaction. Okay, so this is my point. This example you can understand why I'm taking simple example. Right now I have the mobile. Okay, you also having a mobile, but you want to talk to your friend by my mobiles, but I will deny. I will not give you my phone. Why? Because this is my own phone, so I'm locking. So if I'm logged my phone by giving the some pattern, then you try to have my mobile, then you can have no problem, but you can't access the phone. Why? Because that is locked. So when I unlock, then you will able to access. So if you want to talk to your friend by my phone, so first I will do, I will unlock, then I will give you. So after that you will able to talk to your friend by my phone. So this is a my simple concept by which we can apply into the concurrency control system or scheme. So here what we have the two different kind of the lock paradigm. First one is binary log. This binary log can be represented by the 0 1 form, but for understanding or theoretical purpose, it is not good so. But it has a two state. Once again, I'm speaking here. So binary log on the database item can either logged or unlocked state. So we have the two state. One is a log state or an unlocked state. But what is the mode of the locking? So that we have the shared or exclusive. So in the binary log, we have the two state. One is a lock, other is unlock. And this is shared or exclusive. This is a what? This is a mode of the mode of the locking. I can say mode of the locking mechanism. Okay. Okay, it is written over here. This type is the locking mechanism. So mode of the locking, unlocking. Separate the locks in the database based on their uses. If the lock is acquired on the data item to perform the right operation, then this is called the exclusive. So by default, what we have, if we are reading something from the data item by using the locking mechanism, at the time you can use the lock shared. So it can be represented by the lock dash shared, or X is our data item. So at the time what you are doing, you are reading the information. So at the time this thing is known as a shared item. So if you are using log by shared mode, then you can't write. This is a point you need to keep in mind. You can write, but you are using exclusive mode of the log on the data item X, then you can read as well as you can write. So which operations to be applicable inside the inside using the read and write operation. So read write operation is able to use in which kind of the mode. So we need to see lock s, that is a lock shared mode, you can use only the read operation, but in the exclusive mode you can use the read and write. Both mode is also applicable. So this is the point you need to keep in mind while moving to the example. Let me explain. To see over here, see here, log x represent the, we can read and write, but here what we have the log x in transition t2. You can see what we are doing, we are just reading. Okay, we are not writing anything because we have used the lock shared mode only. So we have used a shared mode of the locking mechanism for the transaction. So let me move to the my next part over here. Now see, after this one we have the shared log. Basically shared log is also called a read only log, as I told you into the previous slide. So with the shared log, the data item can be shared between the transaction, but that should be informed the read only mode only. This is a because you will never have permission to update data on the data item. So if the two transaction or multiple transaction access the information, so there will be no issue because we don't have any right to update or anything on the data item. So shared log will be represented by the as, and if you are using the log, so you have to use the log as, like this one. I'm writing once again log as. Okay, and what you are doing, you are unlocking. So then unlock X, unlock S. Now we have the data item X, so that is represented by the like this one. This is the my point you need to keep in mind. Let us understand the example here. Consider the case where the two transactions are reading the account balance of a person. This is a very interesting example. So that's why I've just colorized by the blue color for understanding purpose. This is a very interesting example. Consider the case where two transactions are reading the account balance of a person. Two transactions. Please keep in mind two transactions, transaction T1 and T2. Suppose we have are reading the information of the account balance, so there will be no problem. We can access. So database will let them read the placing the shared log. However, if another transaction want to update their account balance, then it will not be possible. Will not be possible. So this is the point we need to keep in mind. So shared log prevent it until the reading process is over. So because we have used the data item for reading purpose only, so we can't update this point. If you want to update, then what we have a exclusive log, and this exclusive log can be understood by the log X, and data item is X. See, this X is data item, that could be A, B, C, D, anything, and this X is the exclusive symbol for the X exclusive purpose, and lock we are using a locking mechanism. And if you want to unlock such thing, then how we can do? Unlock exclusive mode by using of the data item X. So with the exclusive lock, what you can do, so let us understand. Data item can be read as well as written. Okay, so as well as we can write or as well as we can read. So two operations can be performed with this part, but in the shared mode we can use only the single operation, that is a read operation. So this is exclusive and can't be held concurrently on the same data item. Exclusive locks, that is written over here X lock, you can write this form like, you can write this form like lock X. It's up to you. Okay, so it's up to you, there is no issue. So these are same thing, there is no issue. Is lock exclusive lock is requesting to using lock X instruction like this one. Okay, so I have written over here. And transaction may unlock the data item after finishing the write operation. So this is a point you need to keep in mind. I am repeating once again. Transaction may unlock the data item after finishing the write operation. For example, so when a transaction need to update the account balance of the person, that was we have into the previous example. So you can allow this transaction by placing the x log, that is we can write like this one x log on it, that is x log means exclusive log. And therefore when the second transaction want to read or write exclusive mode, then it prevent from the operation. So if you have using exclusive mode, then other transaction cannot read, other transaction cannot read, because at that time we have a right to we have the right to write something on the our this data item. So this transaction will block the particular data item for other transaction. But if you are using such thing by the shared mode, so other transaction can also access, but only reading purpose. So at the time we need to see when we can read, where we can update. So by the example you can understand in very well manner, but let me know right now once again from your side. In the log based protocol, we have the log, that is a data variable, and that is using the two important thing. One is a log unlock, these are the two state, and it has a two mode. One is a log s, that is a shared locking, and that is another we have the exclusive locking. And exclusive locking, if you are having, then you can perform the read and write operation. And the shared locking, you can perform only the reading operation. So this is a point we need to keep in mind. And we have the example over here. Suppose we have a person, and this person want to two person or the two transaction want to access some information from the same account balance, then we can read, there is no issue. Like this one, suppose you have internet banking. Let me clear to this point with the example, then you can understand. You have the two facilities to access your account. One is internet banking, other one is a ATM card. From the ATM card you can check your balance, and from the internet banking you are also checking your balance. So you and you can able to access the both thing, both thing, or we can say you are accessing your account by the two different mechanisms, internet banking and ATM. So you are seeing your balance, there will be no issue. But at the time two, you are performing two different transaction. One is a transaction one by ATM, and transaction two will be done by the internet banking. But instead of the doing checking the balance, you are transfer some amount your to your friend by internet banking. Let me clear. By ATM card, that is transaction one, you are withdrawing the 5,000 rupees, and by the internet banking you are parallelly you are transferring, on the same time you are transferring 10,000 rupees or 5,000 rupees to your friend. So let me know which operation will perform first, by the ATM or by internet banking. But on the same time we are performing. Please tell me which task or which activity will perform first, by the ATM or
Sir, can you
by
repeat the activities?
question. My activity is saying, I'm saying here, you have a internet banking and you also have a ATM card. From your ATM card, on the same time, on the same moment, you are withdrawing 5,000 rupees, and at the same moment, or same time, you are transferring 5,000 rupees in your friend's account. See, it is not possible to keep the hand by the ATM and the internet banking, but the internet banking handled by your family member at that same moment. So at the same moment, your your brother is sending 5,000 rupees from your account to his friend. At the same moment, you are withdrawing the 5,000 rupees by the ATM card. So see, keep in mind, time is on the same. We have the time. We have the same time. Same time, you are performing the two different transaction. So which activity or which task will perform first, by the ATM card or by the internet banking? This is my simple question. Now tell me. For the seeing the balance, there will be no issue. Okay, for the seeing balance, you can see by the ATM card or
Sir,
by the
it
internet
depends on
banking.
the speed of internet, right?
See, this is the technical issue you're talking to me right now. I agree with this point, but now we are having the good internet connectivity. Even we have the best internet connectivity in our laptop or even desktop or in our mobile. There will be no issue. But here, I'm not talking about the technical issues. I'm not talking about the any technical aspect. Now, see, this is the thing will be managed by the concurrency control in the database. See, while getting the amount from the ATM, maybe the ATM is not functioning properly, it takes some time. Instead of we have the good internet speed, by the mobile we can transfer the 5,000 rupees within a few seconds, even within the millisecond. So depending on the things, of course, I can agree with this one, but here I'm not following the technical aspect. Here I'm talking about the concurrency control. So database will this is to be done by the concurrency control. See, which request is coming from the first, that is by the internet or by the ATM card. So see, it is managed by the database based on the some algorithm, that is database algorithm. So on the base of the database algorithm, first it will check which process is coming first, that is by the ATM card or by the ATM card or by the internet banking. So it will execute first. So you can withdraw, you can transfer the each and everything without any problem, there will be no issue. So at the time you are using the exclusive mode. So here I mean to say that over here it is known as the exclusive mode you are using. So by the exclusive mode you are reading, see, you are checking your balance as well as your withdrawing amount, and you are also transferring the some amount from your friend, there will be no issue. So two different things can be done by, but at a time, suppose we have a something that is to be managed by the database. You have only that 5,000 rupees in your balance in your account, and at the time you are withdrawing 5,000 rupees, then you can withdraw. Now keep in mind this point, you can withdraw. Same time you are transferring 5,000 rupees, that you have only 5,000 rupees to your friend's account. Now, suppose you are withdrawing and suddenly the first process, that is by internet banking, is done. Then now you are not able to withdraw 5,000 rupees because after reading and writing, the transaction was logged. Logged means particular transaction completed. Now you are not able to perform because the transaction is completed and transaction is done. So you have only the zero balance, then at time you will get a message insufficient balance, or maybe the or sorry, unable to process. This kind of message you will get by ATM card. Now, suppose you withdraw, you have withdrawn the 5,000 rupees, and suddenly your internet connectivity is very less, and you are checking the balance after transferring. Suddenly, you will get a message: "Sorry, unable to process due to the insufficient balance in your account." So it depends on the transaction, which transaction is executing first, and which transaction is holding the locking. So now, why it is required? This is the my intention to all the, if you are using the locking based protocol, now what is happening over here, we are using the safety, so we are maintaining the isolation. If we are following the concurrency control, then we are looking for the safety. If you are safety, if you are following the good safety, then we are maintaining the isolation. So one transaction is updated, then we are doing the another transaction, and simultaneously you are performing the both transaction, we are not maintaining the isolation. You are getting the amount from the 5,000 rupees from the ATM, as well as you are transferring 5,000 rupees from your internet banking to your friend. It means you are getting the advantage of 5,000 rupees. That is a not good thing from the database. Okay, bank will lose 5,000 rupees, and definitely bank will ask you or will may call you. Okay, you have to deposit 5,000 rupees, or we can't uh, we can't debit. Okay, we can create the other banks or your friend's account. So we have to roll back. And suppose it is happening, this is my point. Suppose it is happening, I'm coming on that point. Suppose it is happening, and that is known as deadlock. Suppose on the same moment, 10 o'clock or 10 hours, 5 minutes and 53 seconds, you are doing the same operation. And if it is happen, a process is in stuck into one form, that is not deadlock. To avoid the deadlock, we have a time stamp protocol. I was coming on that point. We have the timestamp based protocol. This timestamp based protocol is determining this important point. Suppose we have a deadlock. No more. Now, no problem. You are performing the same two different transaction on the same time, like 10 or 5 minutes, 53 seconds. So at the time, how will manage? And that is to be managed by the timestamp based protocol. Okay. So of course, a deadlock may occur, and log based protocol will fail at that time. So to prevent such things, we have a timestamp based protocol. So I'm coming back to the my this point here. So there are the various modes in which the data item may log, and we restrict our attention of the two modes. Let us clear this as x belong to. Now this is the kind of the truth table pattern we are having. Okay, so this is the shared mode, and this is exclusive mode. Here we have the shared mode, exclusive mode. Now let me clear to all once again. Shared mode. If a transaction Ti has obtained a shared mode lock, that is denoted by the S, of course, on the data item Q, then transaction Ti can read but can't write the Q. You can see over here in the shared mode, if we have the this transaction, suppose we have the transaction T1 and transaction T2. So we have the shared mode by the both transaction, then we can read. So there will be no issue. So it is true. But other transaction is having the exclusive mode, and one transaction having the shared mode, then it will be false. So this can be understood by the example instead of the this point, but this would be clear because this is known as the log compatible matrix computation. This is known as a log compatible matrix computation. So if you are using the exclusive mode, let me clear to once again. If transaction Ti has obtained exclusive mode, that is denoted by the X on the data item Q, then and Ti can both read and write, as I told you so many times. Okay, so if you are using the shared mode, then you are able to perform only the read operation. You can't write. Okay, you can't write this point. But you are using the exclusive mode, then you can only write as well as the written is possible, and it is already written to the my previous slide. I'm showing over here. See, in the exclusive mode you can't write. Okay, so on the exclusive mode we can write, but in the shared mode we can't write. So this is the thing we need to keep in mind. So this is a summary of this table representation, which is denoted by the log compatibility matrix computation. So this is a point where we have over here some theoretical part I'm speaking over here within the 1 minute. So see and read along. You can read along with me. Note that shared mode is compatible with the shared mode only, but cannot with the exclusive mode. But at any time, several shared mode logs can handle simultaneously by different transaction, and it is also possible just like I'm the two different transaction are reading the some information on the same data item. Now it is possible because we are reading, so multiple transaction can read the same data item at the same time. There will be no issue. Why? Because we are just reading, we are not updating any information. But on the same time, if you are trying to update some information, so what will happen at that time? Definitely if the one transaction is completed, then another transaction will complete. So it is required to first transaction should complete first transaction, or any transaction should complete first before reading by the another transaction. So this is the point we need to keep in mind, just like simple thing. uh, this is the my point. Okay, so I'm just coming to my point. A subsequent exclusive mode lock request has to wait until the currently held shared mode lock is released. So this is to be done by the example way you can understand, but this point should be clear. A subsequent exclusive mode lock request has to wait until the currently held shared mode lock is released. So how we can lock the how we can say the lock can be released? So we have the unlock. Okay, so a transaction request is shared lock on the data item queue by executing lock s q. So q is our data item, lock s is we are using the shared lock instruction. And similarly, the transition request on the exclusive mode through the data item queue, and that can be represented by the lock x q instruction. A transaction can unlock the data item by queue by using the unlock queue. So at the time there is no required to specify the unlock x or unlock s. Okay, just we can use only the unlock queue. So there's no need to define especially unlock x or unlock s. Okay, so here we have an example. At the last you can see the unlock a, we have unlock b over here. We are not writing the unlock s, we are not writing the unlock x. So this is the point you need to keep in mind. I'm repeating once again. Transaction can unlock a data item just by putting the message, or that is unlock queue. And this unlock queue is just like a data variable, like log variable. Okay, so this is theoretical part we have done over here. Now tell me, any doubt in this point? In these unlock mode or lock mode, you have any doubt? Please, you can ask me.
No, sir.
Sir, I have
Okay.
a doubt.
Yes, please
Sir,
tell
in
me.
that matrix.
In that matrix. So I'm just moving over here. Yes, tell me.
Sir, here. Sir, could you explain this again?
Yes,
How
yes,
this
it is.
working?
Yes, it is simple. See, suppose a transaction is using shared log shared mode. Then another transaction is want to use. Just let me explain over here because we have some space. Suppose we have a transaction T1 and T2. See, if I'm using any data item in form of the shared log mode, then it is also possible to shared mode, and the transition can use the shared mode. Then it is also possible. Okay, so
Yes,
that
sir,
is
we
true.
can do.
We can do. Okay, just let me use a different color to explain purpose. Now see, now if you have a transition in the shared mode and other transition want to use exclusive mode, then it would not be possible. Then it would not be possible because
Yes,
so
sir.
before the transition should be unlocked. Okay, this is my point. So that's why we have the false.
Okay, sir.
Now clear?
Okay, sir. Understood.
Understand? And same thing we will go for the exclusive mode. So let me use a different color. See, if we have the first transaction have the unlock in form of the exclusive mode, then another transaction we have the shared, then it would not be possible. So it will first transaction should be unlocked. Okay, and same thing will be done by the exclusive mode. Why this exclusive mode? If we are having the exclusive mode, why we can't use this one? Why? because because the this transition this exclusive mode can have the write operation, so it should be unlocked. But in the case of the in the shared mode, unlock is not required because we are just reading information. There will be no issue. And we have some example by which we can understand, and that is known as the delayed unlock. So delayed unlock can be applicable where we have only the shared mode. Okay, so we have this example. Now this example. Look at these transaction. Tell me what is happening over here, and think and tell me. And what would be the value of the a plus b? I just find the value of the a plus b from your side. And suppose I am defining the a's value initially. Suppose we have the rupees 100 by the a, and rupees 200 will be maintained by the b data item. So we have a two data item, one is a and b. And now tell me what would be the output of the a plus b. And so now tell me. And this time I am giving the hint. First transaction we have the t1, and then transaction we have a t2. Now tell me what would be the output. Don't think right now this is a concurrent execution. We don't have, we have over here the serial. Okay, so with this serial, schedule we have. Now what would be the output of a plus b? Now tell me. Now tell me, in the serial schedule, what would be the output of this one, a plus b, and we have the sequence t1 and t2.
300.
300. So how you are getting the 300?
Sir, we have B as 200 and A as 100. And sir, we are subtracting 50 from B, so that is 150, and adding 50 in A. So that is also 150. So the sum is 300.
Okay, now see, first you are looking for the transition t1, so we will understand transition t1. Here I'm using the log x. This log x defining the, I'm using the locking mechanism to lock the my data item for performing the some operation. So see, read operation will read the data, that is a b200. So here I will read the information from the data item, that is 200, and here b will be updated by the, so what is the b will be updated over here, that is a 150. So 150 I can write over here. And after write the operation of the b, so b will be remark, or we will finalize the data of the b, that is a 150 rupees. And here I'm unlocking. So unlocking b, it means now the, now now the, so first let me unmute. Yes, after the mute, now I'm just coming to my point. Now lock and unlock. So by using the locking mechanism, what I've done over here, I've just computed the v's value, or v data items value, that is a 150. Now what I'm doing, I'm reading. Now see, if you are using the lock x, then you are able to use the write operation. But you are just want to read operation, that is a better idea to use only the lock share mode. So in the log ax a, what we are doing, we are reading the value, that is would be the 100 over here, and it will be updated by the 150. And we have the write operation. So with this write operation, the final value of the 150 to be assigned to the is value into the database. And after we are unlocking. So let me know once again this part, this transition t1, what is the sense of the transition t1, and what is happening with the transition t1? Is it clear to all? Is it clear to all? Just tell me, is it clear to all?
Yes, sir, clear.
Okay. Now, so now we are reading the transition T2. So after reading transition T2 by the locking mechanism and the shared mode, and in the shared mode, then you are not able to write anything on the data item A or B. So here we are using the lock SA. It means data item of A will be use locking mechanism only shared mode. So only read only operation will perform. So here we are reading the value of A. So that would be read by over here, that is 150, because it was updated by the transition T1. And now it is also possible. So here we can read the value of the this one, that is a 150. So after displaying over here, the value of the 150 plus 150 will come over here. So 300 will come over here without any doubt. So this is a good point. Instead of doing so, if I'm writing something like this one, now if I'm using first transition T2 and then transition T1, now tell me what would be the output of the A plus B. So what would be the output of the A plus B? Tell me. Again, we have a serial schedule because the transition T2, T1 consists of the subset of the task. So first we are executing T2 and then executing T1. Now tell me what would be the output.
Sir, still same 300.
300.
It would
Because
T2.
no, just first we are reading the transition T2 and then transition T1. So I just need to answer the A plus B. See, in the transition T1, we are not displaying anything. So value will be updated. I agree this point, but we are not displaying. What value we are displaying of the A plus B? That is a 300. So from the transition T2 and T1, we will also have the same value 300 because transition in the transition T2, what we have, we are reading the value of the A, that is 100. And the
Yes, sir.
transition T2 of the value of the B, we are getting the value 200. So we are performing the operation display A plus V, so we are getting the same value 300. So there will be no issue. See, so this is a normal transaction T1 and T2 following by the locking mechanism. So in the serial schedule, it is also possible to use locking mechanism. But in the concurrent mechanism, if you are doing, then how it we can do? So let us understand this concept. One second. So this is a concurrent execution of the transaction T1, T2 followed by the locking. But before coming on that point, just let me know this is the serial schedule following by the locking mechanism. Is it clear to all? We are getting same value doesn't mean.
Sir, could you repeat?
We are using this example. Is there a doubt in this example? First tell me.
No, sir. It's clear.
It's clear because there's no need to use the transition T1 because what is happening over here, you can perform the transition T1 T2 or T2 T1, there is no issue. But after displaying the total balance of the A and B, we are getting 300 and you are doing the some operation, then T1 T2 will perform some operation, and at the time after displaying the information will be updated. And at the time of T1 T2, what we are having, we are performing some operation, we are updating some value of the A and B, and then we are getting the total balance. And the T2 and T1 in this case, what we are getting, we are displaying the first total balance and then updating the value of A and B. So operations or the function of the both serial schedules are different, but but we are getting the same value, so it doesn't mean. So locking mechanisms can be applied, or it is also possible to apply on the serial schedule. It is also possible. This was my point. If it is clear to all, then now read this point and now tell me what would be the output of this one. A plus B, what would be the output? Everything is written over here, and now tell me what would be the output. Everything is written over here, and how we are getting. Yes, now tell me. First see this diagram, and do you have any doubt? Then ask me. In this case, transaction T2 displays the rupees 250, which is incorrect. It should be 300. The reason for this mistake is that the transaction T1 unlocked data item B too early, as a result of the which T2 show an inconsistent state. This is clear to all, or should I explain? This is my point.
Explain it, sir.
Sir, please.
Okay, now see what is happening over here. Yes, of course. In the transaction T1, so concurrency control manager will grant XB, okay, grant exclusive mode of data item B. So in the transition T1, so this is a grant is basically a method which described that we are granting concurrency control manager granting the exclusive mode on data item B of transition T1. So unlock B, so lock exclusive mode B, so we can read. So we are reading the value here. What value we are reading? We are reading the 200 of the B, and here we are updating the value, that is 200 we are updating, so it will be updated by the 150. And after writing over here, so to 150 value will write to the database. So it will write, and we are unlocking. So after unlocking, what is happening over here? It's showing that the exclusive mode is defining over here. We are updating the value on the database, and finally we have done. So no other thing will be applicable. So we are try to read next value from the b, so it will be read by the as a 150 instead of the 200. So this is what this is completely operation of the set of tasks we have done. So this is first task we have done over here. So I'm just marking a line over here. Transaction T2, what we are doing, we are reading the value of A. So we are just only reading, we are not doing anything. So this grant S under the concurrency control manager is showing or describe to us. We are granting the shared mode on the data item A of T2 transaction. So we are reading the value of A, that is 100. And we are unlocking A. So it means what value we have, so we have used. And under the this locking unlocking mechanism. Now, so this is the 100. So we are reading the value of A. So A will be 100. There will be no issue. Now, log S. So we are reading the value of S. We are reading the value of B. We are reading the value of B over here. See, that is 150 instead of the 200. Okay, instead of the 200. Why? Because we have unlocked B over here. If we are not unlocked the B, then we can read the some value that could be 200. But we are but at that time what will be, we can say that is a inconsistent state we can have. But right now we're unlocking. So after unlocking, then you are able to read, then you are able to use this part. Suppose we are not unlocking B over here, then we in the transaction T2, it is not possible to lock you, it is not possible to use lock S of the data item B. So first, if you want to see, that is the transaction T2 should read some value in either X or in the exclusive mode or shared mode on the data item B, that it should be closed or it should be unlocked on the transaction T1. So this is my point. So definitely what we have done over here, first we have unlocked, and the value of the B was already updated, that is a 150. So now we are unlocking over here, and now we are seeing, now I can write like this one, and from this point, and from this point, oh sorry, just let me remove the necessary point. Yes, so in the transaction T2 we are reading, and we are getting the granted, and we are unlocking, and it will display the 150 plus 100 plus 100 plus 150. So what would be the output? 250. So we are getting the incorrect answer, but should be 300, because A balance is 100 and B's balance is 150. So that should be 300, because we are transferring some amount from B's account to the A's account. So A's account is credited and B's account is debited. So this is the point we need to keep in mind. So what is happening? This is an incorrect state. This is incorrect answer we are getting, but it should be 300. Now this part is clear to all. First tell me, this part is clear to all. How we are getting the 250 instead of 300? Or any doubt? Please tell me. Yes, please tell me. Any doubt? Is
sir.
clear to? Okay, just if I'm having a simple query to all. Suppose just let me use a different color to explain my answer from you. Suppose I'm not using this one right now. I'm not using unlock. Suppose I'm not using unlock. We are using the lock exclusive mode B, read B, V, and so on. So now tell me what would be happening. Can we use this point? Can we use this point if we are not unlocking B?
No, sir, I think. Because
No, it is not. It is not possible, because now it is written over here. Now it is written over. Everything is written over here. Now, see, transaction may unlock the data item after finishing the write operation. So what is required? You are writing something, then it is required to unlock the data item, then you can access the data item into the end transaction. So it is mandatory to close, it is mandatory to unlock the data item in the exclusive mode, but in the shared mode it is not necessary. It is not necessary. You are leaving it, it is necessary, but you are leaving, there will be no issue. But in the exclusive mode, in the unlock is required because we are writing something on the data item B, and then the transaction T2 will able to access the data item in locking mechanism in the shared or exclusive mode. But before that, it should be unlocked. So that's why unlock is required. If we are not doing unlocking over here, then in the transaction T2, we will not use the lock S or lock X of the data item B. This is my point. So this is the problem. So everything is okay. Set of tasks, set of activity is okay, but we have unlocked B. It means now we are able to value of the B in appropriate manners. We are reading the value that is 150, which was updated by the write operation. So we have over here. And same thing I can over here. We are reading the value of the lock as over here. We are unlocking A. So here we are unlocking. But if you're not doing so, if you're not doing so, there will be no issue. There will be no issue because we have done use on the read operation. So if you are accessing over here, so if you're accessing over here, there will be no issue because we are not unlocking. We are not unlocking. So we are not unlocking A, but we have opened the A data item as a shared mode. So because we have used on the read operation in the exclusive mode you are want to use, if you want to use the exclusive mode, so we can also read some information. It is also possible, and we can perform the write operation. There will be no issue because we have used a shared mode only. And now how you can say the Shivam asking the question, this is done, this is the point we need to keep in mind. The table will help you. Okay.
Yes, sir. Got it.
Okay, so got it. So this is the point. So unlocking is required, locking is required, what kind of the compatibility we have. But here we have the exclusive mode, then it should be closed. But in the other transaction, suppose in the other transaction we are using this in shared mode, so it is unlocking is not required. It is required, but you are not doing so over at that time, it doesn't mean. But finally, if you're not doing so over here, but then transaction T2, at the last it will be, or at the some moment it should be unlocked. So unlocking locking is where is applicable. This is the part we can see from the compatible. From exclusive mode to shared mode you are coming, then what is happening in summary you can say that should be unlocked. You are coming from shared to exclusive mode, then it should be closed, but you are coming from the shared to shared, then unlock is not applicable, it is not required. It is required, but at the time moment you are not unlocking doesn't mean. So this is my point. So finally, after performing this concurrent execution, it is founding over that display A plus B is getting the answer 250, and that is not a correct answer, but it should be 150. So this is the point. So this is the concurrency control manager. Will see the entire thing like this one. And when truly speaking, grant itself is an operation on the of the concurrency control. It provides the granting or not granting. Suppose this is not granting by the concurrency control. So this is the point. And simultaneously T1 and T2 are executing having the some information. So concurrency control will see which process or which transaction is coming first into the system for execution purpose. So it will grant the on data item, or it will grant the such transaction. So it depends on the concurrency control manager, depend on some algorithmic steps, and that algorithm is known as the database algorithm. And of course most of the part depend on the operating system. So operating system is just having the so many algorithm priority, round robin, first come first serve. So by default we have the basic algorithm that is known as first come first serve, and we are allotting the some time, so we have the round robin algorithm. So depend on the operating system and database mechanism what kind of the granting, or oh sorry, which transaction have the highest granting depend on the concurrency control manager, and followed by the operating system process and database mechanism. So this is a summary of this part. Now it is clear to all. Please let me know. This is clear to all.
Yes, sir.
Okay. So exclusive mode to shared mode you can come, but that should be unlocked. I am repeating once again. And shared mode to exclusive mode you can come, but that should be closed. So we are closing. But shared to shared you are coming. So no unlocking required. Now just let me know here. here we have the different thing. Yes, here now here just let me tell you the example. Any example? No, that example we don't have, but I have the another example. This one. So now move to this part and let me know the point over here. What I'm doing over here. See, see, I'm not following the right now. I'm not using the concurrent. See, transition T1 is having the set of the instructions like over here. You can see lock xb, read b, we have done write b, unlock b, and lock xa, read a, and read a plus b, write a, and unlock a. Okay, this is the I'm just writing this transition into the transition T3. Log x b, read b, b is equal to b minus 1, write b, unlock x. I've started before unlocking b, but before reading, reading b by the other transition. Okay, just let me write over here. Before reading b, before reading b by the other transaction, other transaction, other transaction. Okay, other transaction. This T2 is required to unlock B and A. So this is the point you need to keep in mind. So we can write the unlock in the such a transaction after, but there is a possibility. But if we want to read some value from the other transaction, then it should be unlocked. So we can write unlock. We can use unlock data variable of any data item after the performing or after using the lock of the other data item. So there will be no issue. So we can write T1 as a T3 like this one, and we can write T2 like this one, T4. So here, 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 this concept is known as the unlocking delay. Okay, this is known as the unlocking delay. So we can write T1 as a T3 and T2 as a T4. Okay, so now see, we have used a lock by the shared mode A over here. We are reading and we are not closing, we are not unlocking. I'm just what I'm doing, I'm writing unlock like this one after display over here. So this is known like this one. Just let me write to, and this is done. This is known as the delayed unlocking. This is known as the delayed unlocking. But suppose we have another transition, like I'm taking the tn. Tn is a transition, and this tn transition wants to read some information from the b transition or any transition. Then that such transition, before using the such data item should be unlocked. So depend on the shared or exclusive mode. So this is my point. So this is known as the unlocking delete. Now this is different. This is difference clear to all.
So, sir, in
Yes, tell.
the delete
Yes,
unlocking, we will unlock all the data in the last.
yes, of course, it is required to log. It is required to unlock. If you're not doing so, now what happened? Now see what happened. You are able to the variable that have been updated, that have been logged. So you are not unlocking. Then how you can access? See, just like this is a simple example. I have logged you for a while, but I have not unlocked you. Then how you can move out? Or how you can move out to other places? No, it is not possible. So before that, I require to unlock such variable or such data item. But you can unlock after the sometimes on the not at the same times, after performing its operation, or after performing any so many activity on the such a data item. So you can, it is not required to unlock on the same time. You can unlock after sometimes, or you can perform any other operation on the data item, other data item. There will be no issue. But before using such data item by the other transaction, I'm repeating once again, by the other transaction, if you want to use same data item, then it is required to unlock. This is my point, and that is known as the delete. So you can see, after performing all the operation of the b, I'm unlocking over here. But in the transition a, in the transition t1, I'm using data variable. So after performing, I'm unlocking A over here. I'm unlocking B over here. But in the tangent T3, you can see after performing all the operation B, and I'm also performing some operation on A by locking mechanism. And at the last, I'm unlocking B over here. I'm unlocking A here as it is. And this is the point. This is my point where I'm writing the star or design the star. And this is known as the delayed unlocking of the B, delayed unlocking of the B. But if we want to see use this B by the other tangent T5, T6, and T7, just suppose that, then it should be unlocked. If we are not unlocking, suppose we are not unlocking, and we try to access by the other tangent T5, T6 of the B variable, so it will give an error or it will message. The transaction T1 is still using the this variable, so it should be unlocked. This is my point. Now this is related to unlocking delay.
Yes, sir. Understood.
Okay, so this is a little bit different. We have to keep in mind. See, understand database is very easy, but each and every point we need to clear. Okay, so that's why I'm just taking different example to tell all the things. Now, see, so you should verify the sequence of the read and write in the schedule one. And what is schedule one? That is we have seen over here. This schedule. Okay, this schedule, this one schedule. Okay, and which lead to the incorrect total value 250 we got, and being displayed, that is we have calculated how we are getting, and is no longer possible by the T3 and T4, and other schedule is possible. So T4 will not print out the inconsistent result or in any of them. See, instead of the T1, T2, if you are using the T3 and T4, then is it possible we are getting the right answer or not? So let me check. Okay, this is the exercise. Actually, I have a planned exercise. So see, T4 will not print out an inconsistent result in any out of any of the them. So T3 and T4 we have. Now see, T3, T4 we have. So instead of using T1 and T2, we are using T3, T4 here. Now tell me what would be the output. So what would be the output? That is the part I'm leaving. So what I'm leaving over here now, see,
Sir, it is getting late.
you are moving to the other class. Okay.
Yes, sir.
Okay. So just give me 1 second.